I'm CK. Today we've got another kit from MiOYOOW. I can never pronounce that well. I'll keep doing their kits even though they've blocked me from posting reviews on Amazon, I guess because I was too honest about some of their kits. But I hold no ill will. I'll still keep doing their kits. This is a little electromagnetic coil. Looks a little bit different than another one I did, looks a little more extensive, so it'll probably be pretty neat. So we'll put it together, play with it, and see how much we learn. And I hope you enjoy the video. The box, MiOYOOW soldering practice kit, electric. They left off stuff new. There's the part number, made in China. Take the bag out. Get the box ready for recycling. And let's get at the bits in the bag. There's a piece of paper to tell us how to put it all together. High voltage electromagnetic transmitter DIY kit. I guess they wanted to avoid using the G word, the G-U-N word. 6-volt high voltage electromagnetic DIY kit can turn electrical energy into magnetic energy, sending it into a metal cylinder. So it'll spit a little cylinder out. And QR codes for the assembly manual. And a warning that the circuit board voltages can reach 210 volts, so don't touch stuff. Always a good idea. Nice component list. Here is a piece of wood that is the mounting board. It's got laser cut holes in it. The laser was kind of broad on this. It's really scorched around the holes, but it's probably working overtime cranking out parts. Here is a big old cap, 240 volts, 680 microfarad. Electrolytic to store the energy to release all in one blast through the firing coil. Here's something that looks like a holder for the firing coil. Here's a, oh, it's a digital display. I wonder what that's for. I think this is one of the little, I think it's one of the little voltage displays, but I don't know why that would be in there. But we'll find out. Some rubber feet. What's in here? Oh, here we have a number of metal cylinders that we can project through the device. We've got a 6 AA cell. 4. Count 4. There's not 6 here, obviously. A 4-slot AA battery holder to give us 6 volts. Here's the actual transmission coil and a little, looks like high-quality plastic tube and a backstop on the tube so you can drop stuff right on in. Some tie wraps to lock everything down. And then the circuit board. Let me get another parts bowl for this guy. See what's in here. First we have the circuit board itself, and it's higher quality than many of these beginner type kits from MiOYOOW and others, Ding Dong Store and others. It's all through-hole plated, which is nice, and we've got, see these big traces that are coming from, where does the big cap go? Okay, so the big cap lays down here, and these traces carry the output from that to J2, which I assume goes to the coil. Could be wrong, because J3's, what would J3 be adjusting? I don't know. We'll take a look. So, because it's got a lot of voltage, it can't use one of these regular traces to safely send that much voltage along. Now all the component part numbers, well, most of them are, but not all of them, because there are a couple of potentiometers that I'm not sure are all the same value. Got some resistors, a diode. Oh, look at that. They put the resistor values on little paper tape, which is always nice. Diodes, resistors, diodes. A inductor. I think that's an inductor. It looks like it's a dual inductor, or it may be actually simply be a transformer coiled differently. A little switch with a button cap that's kind of askew. And we've got other switches. We've got a couple of other switches which are bigger and have green and red caps. That must be fire or cancel. Maybe it's got a discharge circuit in case you've charged up the capacitor and want to discharge it. That would be nice. Then we've got a number of MOSFETs. And this one, I'm just thinking, if it takes a while to charge this, I may want to put an additional heat sink on here, but we'll investigate that along the way. We've got a red LED and a green LED and different size junction boxes. So that's it. It looks like a pretty straightforward build, and fortunately for my coil winding skills, the coil's already wound. That's nice. So I'll get the soldering iron heated up. We'll pull the build guide up on the iPad and put this little guide together. So they do have a build guide. It's rather comprehensive. It's got a bunch of text in the beginning which tells you how to do it step by step through text and a finished picture, which is always nice. And then each step with an illustration as to where it all goes. So very good build guide for sure. And I forgot to point out they do have the schematic here, which shows you pretty much that it's a simple circuit. You've got the two buttons are charging the capacitor and discharging the capacitor. So it's got LEDs showing you what you're doing, some current limiter resistors for those LEDs, then that inductor to boost, that transformer inductor that I showed you earlier to boost it, the transistor which allows charging to happen as it's tapped off the boost indicator, a boost inductor, then a diode and the Zeners, and then the discharge coil, because where is the capacitor? Here's the big capacitor. So that's all charging up, and when you push the red button to launch it, you'll trigger this guy here, this transistor, or the BAT116 diode. I believe that's a diode. BAT116. Oh no, it's not. It's neither. It's a thyristor, and that will open the pathway for the discharge current to blast through the coil. And there's a voltmeter. That's what the little display is to show you how charged the capacitor is. And now we're just going to go through this in sequence. We're going to do the three 1K resistors first. We'll do all the resistors first, as is typical. And this will be R1, R4, and R5, but we'll do just one live here. I mean regular speed. R1 is around here somewhere. There it is. So you do not have to bend the leads all the way up to the resistor bodies. You can leave a millimeter or two at each end. So let's see how well the board takes solder. Very well, as one would expect from a quality through-hole board. Now we'll put the rest of the resistors on. I'll speed up camera playback because we don't need to see it. Detail on each of these, and you can just enjoy resistor time. And that's all the resistors. Interestingly, R3 is a 51 ohm resistor. I'm not sure I don't recall ever using a 51 ohm resistor before. Just interesting. Now we'll put the two diodes on. White stripe on the diode, or silver stripe on the diode, and you'll capture it. And we've got two different ones. We've got Y22 220. So we'll keep these leads because they say we need them. I don't see any jumpers on the board, so I don't actually know. I haven't looked ahead, so I don't know what we're going to be using these for. But we'll figure that out, won't we? And now we'll put the buttons on. That's on nicely. Now we're going to put the power transistor at Q1. We will make sure we get it the right way. You can tell it's the right way. First, it's got the emitter, collector, and base indicated, so you could look at the data sheet, or if you know how a power transistor works, you'll know. And this is a 438. Nope. There's the 438. Oh no, I'm sorry. It is 438. At Q1, the heat sink goes to the side where the heavier line is on the outline of the component. I'm just double checking against the picture, getting my orientation right. Yep. I knew the way it's supposed to go. However, if they give you pictures, may as well take a look at them, just to double check yourself. And now we're going to put the inductor on, and the long pins connect to 1 and 2. So the long pins, or I'm assuming that's the primary side, but I'm not sure. I'd have to look at the board. Where's the connection to the capacitor? I'll figure it out. Let's see if we can get this flat. Nope, the holes are not spaced completely well enough to get the inductor flat. And now we'll do another. We'll put the BAT 16A. Is that what this is? Nope, where's the BAT 16A? No, that's the other. Oh no, that is the BAT 16A. Thyristor at Q2. Even though it's labeled BT A24 8008, but that is what they are showing here. So that's what I'll go with. And again, same thing. The heat sink goes to the side that shows the heavy line. And you can see that's, as I showed on the schematic, that's what triggers these heavy traces to pull the power from the capacitor and send it out to the coil. I'll get to soldering these in a minute. Wait, where did I miss? I missed one. Where did you tell me to, when did you tell me to put this one on? Or did you give me an extra one? I think they gave me an extra 438. Well, that'll go in my spares box because there's no place to put it. What does it say here? No, it says it's only supposed to be one. So I've got a spare power transistor. Good. Put it in my... I have a box that I keep all the spare parts, extra parts that show up in kits. And I have quite an extensive collection by now. But it's good for spare parts if another kit doesn't contain something. You've got it right there. Or if you're going to make your own design, you have some prototype parts that you can play with. Or if you just want to see like how that transistor works, you can put it on the breadboard and play with it. I want to put on these heavy traces, I'm putting quite a bit of solder to put a good bit of surface area of solder on these heavy traces around the pin. All that. Now we're going to put the colored caps on so we know which button is charge and which button is fire. It's always one of the harder things for me. It's charge. This is fire. Okay, now we're going to put the cap on the board. And that's what the tie wraps are for. And we're going to take the cap out of here and I'm not going to touch the leads right this second because caps can get an atmospheric charge. They can be charged just sitting around. So what I have is I have my little discharge tool. That I use for guitar amps to snuff out the charge in the capacitors, the 400 volts in there, and because you do kind of want to be careful about that. So we're going to be putting it here with the stripe side going, negative side going against the shaded area. So first, before I do that, I will weave our tie wraps through the board. Pulled it it slipped out and I pulled the tie wrap too tight. That's okay, because if there's one thing I got a bunch of, it's tie wraps. I'll be back in a second. I have tons of spare, I have tons of tie wraps, I've got tons of spare resistors, I've got tons of pin header strips, because I use those all the time when I miscalculate or when I mess up, cut the pin header. There we go. Make sure that's all flat and nice. Snug that down. Get one more thing back. Now next, this is what we're using the diode leads for. We're going to connect the pins to the holes here with the diode leads, which is probably good because they're a thicker gauge than, say, resistor leads. And I'm going to flip my solder pad over, and I keep looking up because the cameras are going to be timing out here in a minute, and I want to get this on camera. So I'm going to flip the board over, soldering pad over, so I can have that. Golly, it's stuck to my finger. So I can have that lead dropping in. This is another case where I'm going to want to use a good glob of solder. That's good. Okay, we're going to be doing some other mechanical assembly here, so I'm going to turn the cameras off and back on because I've only got 30 seconds of runtime left. But before we do any of the mechanical assembly, I forgot to put the LEDs on. Red LED goes here, and there's a plus sign on the board to show you where these go. Green one goes which way the long lead goes, that is. Get that one in there. That one in there. Now at this point he interjects, or she interjects. You want to scrape some of the lacquer off the wire coming out of the coil, because it's going to make a connection to the junction dingus. So I'll get my more than 60-year-old Wilson high-speed razor blade. I'll tell you, someday I'll tell you how long I've been carrying these around and why I know they're at least 60 years old. But it still holds an edge. You can still scrape. We want to get this insulation really off. We want to have a real clear path for the electricity to go racing down. We don't want to have a partial contact. We want to have as much surface area captured with bare wire as we can get. Obviously you can use a knife blade or X-Acto knife, even a good pair of scissors can give you a surface that can scrape off this lacquer insulation. I'm taking about a 1/4 inch off, 5 millimeters or so off, which is probably more than I need, but okay, those wires are bare. Now we're going to put various things on the board here. We're going to put some mechanical stuff. Oh, here they are. We've got our little insulating standoffs. We're going to put here, because that's where the circuit board's going to go, and we want to make sure that these traces are not just hanging out there for the public to enjoy, because somebody could get hurt. Put the screws in loosely as I get them all set up. Okay, I'm going to take the 3D printed base. That's all the stuff in this thing. Let me put this switch cap on here. Let me get, actually I'm going to, since I've got them, I'll use another part pin for this one. For these parts, that'll hold the launcher tube. It's kind of cute. So these are all 3D printed, you can feel it. And we're going to put that there and use two of the, which screws? Those screws. So tighten these down. I'm tightening these less than I tightened the other ones. Just because this 3D printing stuff can be a little fragile. Okay, there's the base. Place one-piece 3D printer bracket on the 3D printer base. Note, the size of the hole can be adjusted appropriately using tools. Yes, I'm sure it can. I'm going to see if I can get it on there without using tools. No, the hole's not quite big enough because it's supposed to go on there and then swivel around. Let me get a little file. A little round file. I'm doing this off camera because I don't want to get the plastic dust on my workbench. That works. Now it swivels. Swivels all nicely, yes. Now we take the broad head screw, this one with an integrated washer, and we will put that on this in the center here. And that will be our swivel point for aiming our launcher. Again, we'll want to make sure we don't tighten it up too much. It shouldn't tighten up too much, but you can't be, because there's a little raise on it, but that's fine. There, that works well. Now we're going to take our other bracket and these two brass colored screws, they're not actually brass, and put them in here as our elevation adjustment screws or pivot. Of course, now I gotta get it right in the correct hole, so I'm gonna tilt this up a little bit so I can look in there. The screwdriver's too thick for that. Let me get another one. This will be much better. Take my resistor lead out and get this one set up. Want it a little stiff. So now we've got azimuth and elevation control. Not as much as the 16-inch guns on the battleship New Jersey, but plenty enough. Now we're going to put the battery box on. And it connects to here. That's our input power. They say to trim the wires a little bit. I'm not going to bother doing that. You might want to if you want it to look a little neater. And now we're going to put the red wire in this side of the terminal block. Make sure it's in there tight. Give it a good tug. Good too. If things don't work on something like this, always check those terminal blocks first, because they're often can be a little flaky. Now we're going to put the voltmeter, which is in this bag. There we are. You can see at the bottom of the display there are dots. That will be what you want to have facing down. Now this, you don't need screws because it's got little bayonet clamps that go into the square holes. Ooh, not very well. It doesn't give me much firmness. Unless there's another escape path for the wires, but I don't think there is. I guess that'll have to do. Now we're going to put these in this 3-terminal block, and we've already got some stripped wire here. They again say you can should probably trim these wires down to about 100 centimeters. I'm not going to do that, but what I am going to do is, as you can see, as I'm pulling this insulation off, I'm twisting it to twist the strands of wire in here together, and now I'm trying to position it to get a pair of scissors. Tweezers. Some tweezers. Hold it kind of like that, and now I'm going to tin these wire strands. Where's it better? So they don't fray and I get good connection in the junction block. Now, black goes to the center, red goes to where there's a plus sign, and then there's a squiggle line, which is the voltage sensing line. And I just put my screwdriver away. thought I did. I did, but I missed it. Didn't go in its regular spot. That's no fun. So we'll put the yellow sense line in. Black into the negative, as one would expect. That didn't go in again. I never have liked these very much. And that voltmeter is just not staying in those holes. I'll have to work on that. I may have to epoxy that or put some wood glue around it just to keep it from flopping around. And the red lead in the positive marked spot, of course. That's all good. We'll put this back in, maybe, if it stays. And now we're going to put our cannon, our launch cylinder, inside this 3D printed bracket. Hopefully I can do this without damaging something. There it goes. And these two leads, which I scraped the insulation off of, will go in there and there. It doesn't matter which lead goes in which spot because it's just going to be creating a magnetic pulse. Doesn't matter what direction the magnetic field is going because the metal projectile will be kind of back here, so any magnetic impulse will pull it out from there, so you don't have to worry about the polarity of the magnetic field. Ta-da-ta-da! There we are. Except for this not fitting in the holes very well, and part of that is because the case they've made for this doesn't have an escape cutout for the wires, so the wires are pushing it up. You need to have a little cutout to do that. So let me go get some batteries and get a little area, get the area here set up a little bit better for giving this a go, and I'll be back in a flash. Now we'll get this thing fired up. I've got 4 rechargeable batteries on board. I also put the rubber feet on the bottom. I'm sorry, I skipped that earlier. So we'll turn the power on. Oops, my voltmeter came loose again. Again, that's at least somewhat better. Now we'll use the green button to charge it up. It shouldn't go above 200 volts. I'll try to keep my arms out of the shot. It's supposed to stop at 200 volts. Green light comes on. It starts about 218. Okay. Now we'll put a projectile in the impeller. Tilt it back a little bit. Now we'll aim it at the target, which is one of my parts trays, and we'll fire it. Well, that was pretty good. It made quite a clank. Let me recharge it and we'll do it again. It's 200 and kabang! Even knocked it over a little bit. Okay, I'm going to switch camera angles and I'll be right back. I'm focused right down at the muzzle of the impeller. So we'll charge it in again. Let me run back over to this other camera and double check to make sure it's still in focus. It is. And powering it up again. I have no idea how many charges I can get out of 6 volts of battery. Okay, and now we fire again. That's pretty neat. So it works very well. It's got a great schematic so you can see what's actually happening here. It was relatively easy to put together, and a fine demonstration of electromagnetic force. And I hope you enjoyed the video.